Hello, everyone. Welcome. Thanks for joining us for today's session on exploring your data with OpenRefine. My name is Molly Webb, and I am here with my colleague Doris Scott, and we are a part of the data services team at the university libraries. Today, we plan to show you how you can get started using OpenRefine, installing it and running it through a web browser. Then we're going to go through a series of demonstrations for some of the common and helpful workflows that are possible with this tool. So let's get started. What is OpenRefine? So here is the tool's tagline, a power tool to deal with messy data. You import your raw data, whether it be CSV, text files, XML, JSON, and the OpenRefine application gives you access to many different data exploration and editing tools. Once your data has been cleaned and normalized, there are also many options for exporting the data back out. And so we're going to look at a few examples from each of these steps today. But first, installation. We're going to assume that you haven't yet installed this application on your machine. All you need to do is go to openrefine.org and then find the download button, which is going to be on the left-hand side of the screen in the navigation menu. The latest stable release is going to be listed at the top of the downloads page, and currently the latest stable release is 3.4.1 as of September of this year. Depending on your operating system settings, you may receive a warning message when attempting installation, and so you may need to make some adjustments to your security settings in order to allow the download. Doris and I both found that this was the case when we attempted to install the application on our Macs. After you install the application and when you open it, it's actually going to open up in a web browser. We can see the URL here, the local URL at the top. The application is going to run in a tab on your web browser. You should also be aware that since OpenRefine is running its own little mini web server in the background, you may experience some issues when attempting to access other internet sites when you're running OpenRefine. Okay, so when you open the OpenRefine window, this top portion here lists all the different native file formats that OpenRefine is able to open. And then you can also add some extensions for additional file formats. When you select a file or multiple files to bring into OpenRefine, there's going to be a lot of different options for parsing the data, including the very helpful trim leading and trailing white spaces from strings. If you've ever worked with any kind of free response text, I'm sure you'll understand how helpful it can be to take care of these right from the start. You can also indicate whether you want to keep blank rows when you bring the files in or remove them immediately. That can also be helpful to take care of right at the start. Another helpful parsing parameter is the text encoding on import. So encoding is the way that your computer matches up the text characters coming in with the bytes it uses to store the information. So each of these options represent a different way to map these characters, and choosing the right one helps with the general readability of the text. It can also make sure that your computer can process these characters properly. If you're not sure which encoding to use, chances are whatever is selected as the default when you bring in the files will be fine. Right here, I'm showing UTF-8, which is a widely used encoding, and that's probably okay. But if you do bring in your data and find that certain special characters are not displaying properly, then you may want to consider exploring other types of encoding. Okay, so today we're going to go through some common workflows for OpenRefine, including faceting, clustering, using GREL and regular expressions. GREL stands for General Refine Expression Language, and it's an expression language used in OpenRefine that's designed to resemble JavaScript. And also, I think it kind of resembles Python too. Its formulas It has formulas and variables depending on what data type, so you can do things like string manipulation or mathematical calculations. And also, another cool thing about OpenRefine is that we can play around with the data as much as we want because we aren't actually changing the original data. And if we don't like the results from a particular step, we can always undo and redo.
So then I'm going to go over faceting. Today we're going to demo some of these, but some of the most common faceting that you can do with OpenRefine. So you're essentially just grouping things together is text facets, numeric facets, timeline facets, scatter plot facets, and then you can customize your own facet. So the one powerful thing about OpenRefine is that you can find values that are similar to each other, and then you can change them to a more standardized value. For example, in this screenshot, there's this name that is actually the same person, but the spellings is slightly different. So you can standardize this to like when you choose like what's the proper spelling, you can get these values in the cluster and change it to the new cell value. Also, Molly touched upon this a little bit before, but another powerful feature of OpenRefine are regular expressions. So essentially they are wildcards on steroids. So for example, if you have a bunch of textual data that has dates, you can actually use regex to create some kind of string or group of characters that will find dates in a particular way. And this is very useful in terms of finding dates or just finding like particular names of something that you're looking for. So the sample data that we're going to be using for the demos is data from the A to Z database, which is a library. Our library has a subscription to that. And so our sample data is of 2,100 grocery stores in the US. And we're just going to play around with this data right now. So I am going to switch over to the OpenRefine interface. And can everyone see this?
Yep, we can see your OpenRefine window, Doris. Thanks.
Yeah, please let me know if you can't see some of the options, because you should be able to based on my screen sharing. So there's many tabs here. And so if we want to create a new project, we just make sure that the create project tab is highlighted. And so I'm going to first choose my files. And so there are 20 files here that I'm going to choose. Hold on, I need to. And so I'm just going to shift and click open. And now you can see that it shows that there are 20 files. And the nice thing about it is if there's a little pop-up that shows you all of the CSV files that we're going to import. Then after that, you can see more of the, the name, the media type, the format, and the size. And if everything looks okay, you can also choose to deselect some tables that you might not want, but we're going to keep all of them. So next, I'm going to configure parsing options. And as you can see, you have like the options here on how to parse the data. And you get another preview of like the file and then just the entries that are in the file. So we're not going to change anything here. So now we're going to create the project. And it is pretty quick in terms of how fast it loads into the system. That was 20 data sets and it did it pretty quickly. And there's 2,100 rows here. So the first thing that we're going to do is do some text faceting. So we're going to group values together by their classification. So we're going to do this to the primary SIC description. So I'm just scrolling over here. So this is a primary SIC description, and I am going to click facet and then click text facet. So one question that you can follow along in the slides once you get them for your own, like to do this on your own. But one question I had was, what's the classification that shows up the most? And it's grocery stores. So you'll see the classification and the number. And this is really nice. So the next thing I'm going to do is do numeric faceting. So I'm going to do this with the 2019 sales growth column, which I need to, there's a lot of columns. So right now, it is not transformed into a numbers data type. And I can show this by trying to facet with a numeric facet. It says no numeric value present. If this happens to you, what you can do is actually transform the cells from text to number. And it's really handy that OpenRefine has the common transforms. So I'm going to click to number. And then you can see that it transformed in the number because it is green. Now, if we do the numeric facet again, we actually will see the sales growth. And so one question I had exploring this data was, what was the range, which you can see is negative 50%, so negative growth, to 42%. Another nifty feature of OpenRefine is timeline faceting. So we're going to do this with this year established field. Again, I'm going to show you that if you try to do a timeline facet when the text color is black, it is not text. The NaN stands for not a number. So you're going to have to actually transform the field to a date field. So I click on edit cells, common transforms to date. And then it's going to use a particular format. So it turns into a date field. Now, if I do the facet again for timeline, and I wanted to know, say, the period in which the most stores were established, I can just use this little slider here and zone into that. Oops. And one cool thing about OpenRefine is that it also narrows down the rows. It filters those rows based on what you do with the slider. So the period that has the most stores established was between 1931 and 1951. And there was 694 stores that were established.
Correct. So the reason why these files came in so nicely was because they had the exact same column names. And that is often the case if you're downloading data from websites that say maybe only let you download a page at a time, or if they only provide data for certain time periods and like say monthly data, and then you need to slurp them all together to create a full year's worth of data. They do need to be all formatted the same to have it happen as nicely as it does. If they have different column names, then what you're going to see here is, say at the end, you may see some columns that appear, but they have null values for some of the records, and that would indicate that that column does not exist in one or more of the files. Thank you. That's a great question, because it is often the case that we have to deal with files that might have the same data but different column names.
Someone asked, is OpenRefine HIPAA compliant?
Yeah, and if you look at some of the documentation for OpenRefine, they do address that question. So when you download OpenRefine, it is running on your local machine. So it's not putting the data out to the internet and then bringing it back or anything like that. It's all happening locally. So technically, if you are working in a secure environment with your machine, it is HIPAA compliant because it's not sending the data anywhere. I hope, can you still see my screen? Yeah.
Yes, we can.
You can see here this local URL here. This local IP address. So even though we are using a web browser, it's not sending any data over the internet. And they do have more information regarding HIPAA compliance in their documentation if you want to check that out to be sure. Okay, so I'm going to take a look at clustering. So again, when you have any kind of textual data, it is likely that there's going to be differences in the way that that data was brought in. So we're going to check out clustering on the business name column here. So you can get to clustering a couple of different ways. You may have noticed that when Doris did the text facet, so clicking this drop down arrow next to the business name column and going to text facet, a cluster button does appear next to the text facet window. So we could click on that and work on our clustering in that way. And I'll just close that. Or we could go to, again, clicking the drop down next to the column, going to edit cells, and then cluster and edit. So there's a couple of different ways you can get to that window. When we open up the clustering window, it immediately uses these default methods and functions to evaluate clusters. And right away, we can see that in our 2100 records, we have found at least two clusters, these two different supermarket types. So after we do some research and figure out what the name that we want to be coming out, do we want an apostrophe S or do we not? We can change that value in the new cell value field, click merge, and then these now anything that was this true cheese without an apostrophe S will become a true cheese with an apostrophe S. So we can click merge selected and recluster, or we can click merge and close. So I'll just say merge selected. And then now it's saying, okay, no more clusters. Well, that may not exactly be true. I mean, we do have over 2,000 records here. So I don't quite believe that. What we're going to do is we're going to try adjusting some of our clustering parameters here. So we'll stay with the key collision method, and we'll just choose a different function. Now, I'm not super familiar with the backend calculations that are happening, but there is a lot of information about finding different clusters of words, and so these can be explored depending on what your needs are. Once I've chosen a different keying function, then we have another cluster popping out, Joule OSCO. Okay, so let me double check. What is Joule OSCO? Is it Joule hyphen OSCO or is it Joule space OSCO? Well, we've got 44 rows that are Joule hyphen OSCO and one row that's Joule space OSCO. So if I looked it up on the official Joule OSCO website, I would see that it's actually Joule hyphen OSCO. So I'm going to click merge and select and recluster. And so now it's cleared out those clusters. So let me try another keying function. I'll just go down to the next option here. And so here is a function that has brought out many different types of clusters. So again, we can go through and we can figure out which ones we want to keep here. So this is just a really easy way to see all of the unique values that might be coming through in a particular column and do that cleanup immediately without having to, do a whole lot of filtering or data entry or anything like that. So very handy function there to clean up values. Okay, so the next task that we're going to tackle here is going to be using the general refine expression language and regex. So I'm going to scroll over here, and let's say I want to do some filtering of my records based on the revenue per year. Okay, so I'm going to try to do a numeric facet just like Doris demoed for us. So I'm going to go click the drop down menu next to the revenue per year, go to facet and numeric facet. Okay, so again, I'm going to get this note here saying that there are no numeric values present. Knowing what I know about how computers need to read numeric values, I can pretty much assume that what's getting in my way here are these commas and probably these dollar signs too. OpenRefine's probably saying, hey, there's actually alphabetic characters and special characters here. And so I'm not recognizing this as a number. So let me close that for now. So to fix this, I'm going to go to Edit Cells and then Transform. And this is going to open up this custom text transform window. Now, like I said, the GREL is very similar to JavaScript and Python. So it has some of the same functions you would expect to do string manipulation. One of those functions is the replace function. So most of the time when you're doing replace, the function has two parameters. You have the value that you're looking for and then the value that you're going to replace. So I'm going to just say, okay, take my value dot replace. And so I need to give it a function that I'm looking for, or excuse me, values that I'm looking for, and then I need to give it a value to replace. So my value to replace is just going to be an empty string here. Technically, I could just say, all right, replace all the dollar signs with nothing. The left-hand column is going to show us the value that's coming in. And then the center column here is going to show us what that value is going to look like after the replace happens. So here I can see that all of my question mark, or excuse me, my dollar signs have gone away. I could hit OK, and then they'd all be replaced. I could open it back up and then maybe put my comma in there. All the commas have been replaced, and so on and so forth. But say I want to try to do my replacements all at once. Well, that's where the regular expressions come into play. And so I'm just going to flip back to the presentation really quickly because I want to show you how we can parse out the regular expression we're going to use. Okay. Here's where we did just the regular replace, and then here is what our regular expression is going to look like. So we're still using the value replace. We still have the empty string that we're going to use to replace the values that we find. But what we're going to do is we're going to enter in a regular expression here as our first parameter. So regex expressions within OpenRefine are going to be encased in these forward slashes. So here is my forward slash that starts my regex expression, and here is my forward slash that closes my regex expression. So this middle part here is saying, okay, find dollar signs, and then the pipe operator stands for or, and then the comma just stands for a regular old comma. So I'm saying find dollar signs or comma. However, the dollar sign is actually a reserved character in regular expressions. It means something else. So we need to use an escape character in front of our dollar sign to indicate to the computer, yes, I really am wanting to find the dollar signs instead of using the dollar sign as the reserved character that it is. So we start our regex expression, we escape the dollar sign, so we find dollar signs or commas, and then we close the regex expression. So let's take a look and see what that looks like here. Okay, so the first thing I'm going to do is I am going to get rid of my quotation marks and start my regular expression. I'm going to type my backslash so I can escape my dollar sign. And then I'm going to say or comma. So now in my replaced column, I can see that all of those dollar signs and those commas have gone away. I can hit OK. So it transforms 2200 or 2100 cells there. I can see that they're all numeric values now, or at least they look like it to me. Let's check them out. So I'm going to go back to edit cells, transform, or excuse me, common transformations, and then to number. All right, so now all 2100 cells have been transformed to number. I can see they're showing up in green. So now I'm good to go with my numeric faceting. So I can go to facet, numeric facet, and I can see the range of revenue per year that we're seeing here. Okay, so next, I've been looking through this data and I can see here that we have a latitude and a longitude. And being a GIS person, to me, that means that I want to make a map with all of these business locations. I want the business locations to be represented as points in the map. All right. Well, so what I could do is I could go to export. I could export this table as a tab separated value or an Excel file or a CSV. I could bring one of those tables into a GIS application and I could use that to create a map where points are placed at the latitude and longitude. But also being a developer, I don't want to do that. I want to create my own custom map. And to do that, I'm going to, let's say, you make a web map where I'm going to need to bring in my spatial data as a GeoJSON file. So GeoJSON is a special format of JSON that holds spatial information. And the basic outline of the JSON is everything is wrapped in these curly brackets. And then we have additional key value pairs that represent the properties, so essentially the column names and their values. And then we also have key value pairs that represent the geometries or the shapes. In the case of points, we're going to have a coordinate pair, a latitude and a longitude that tells us where that point is on the Earth. All right, so this is one of the really cool functions of OpenRefine is that it can just export this into a JSON file really easily. And I can add additional information to make sure that this comes out as a GeoJSON file. Before I do that though, I might want to do some checking on my latitude and longitude values to make sure that they make sense, that we don't have any points that are going to show up in the wrong place or whatever. I know that all of these values are in the United States. And so essentially we are going to expect that all of the latitudes are going to be positive values and all the longitudes are going to be negative values. So there's just like a little geography lesson there for you. Latitudes above the equator are going to be positive. That makes sense. And then longitudes that are west of the prime meridian are going to be negative. So I can do a little numeric conversion here. So I can go to edit cells, common transforms to number on my latitude, and then I can transform my longitudes, edit cells, common transformations to number there. And so then I can do some numeric faceting just to check the ranges and make sure that they make sense. So my latitudes run from 21 to 63. They're all positive values, so that seems pretty good to me. And then I can do a numeric facet on the longitudes and see that they're all negative values. And so great, that means that the latitudes and the longitudes are at least showing up in the right quarter hemisphere. Now to export to my GeoJSON format, I'm going to go to export, and instead of choosing one of these tabular exports here, I'm going to go to the templating function. So what we see here is that it has entered in a prefix, which is going to kind of open the JSON, and then a row template, meaning that this is the records that are going to appear for every single record in my file. So if I scroll down, I can see all of the columns that we had, and then the values get inserted for the different records. So all of this is one record here. And then when I find the closing curly bracket and the comma, this is the start of the next record. So I'm going to input some text into my template to make sure that it turns out okay when I do my export. And so I have this kind of pre-made here. I'm just going to do a little copying and pasting. Okay. So for my prefix, I'm going to put in that it's going to be a feature collection, collection of points. And then for my row template, I'm going to copy this in, give myself a couple of extra lines of space and paste this in. And so you'll forgive the messy indentation, hopefully. But now I can see that at the beginning of each row, I'm going to have my feature. I'm going to have my geometry where the longitude and the latitude values are going to be inserted based on whatever's in the record. And then I'm going to open up my properties section, and then that's where all of the values coming in from the other columns will be. Okay, so that looks pretty good to me. I'm going to leave the row separator and suffix the same as they are. So now when I scroll down and look at my next record, I can see that it's inserted another feature type in there, and then it's showing me the properties. Let me just show you that one more time. There we go. And it's swapped out for the new latitude and longitudes that are specific to this record. So now I can click export. It's going to let me export that. I'll export that as a JSON file. It's giving me a warning about the JSON file extension. That's fine for now. And so now if I open this file up, then I've got the JSON file here with all of the information for all of the records we brought in, and I can use that in another application, whether it be my web map that I'm going to create or some other application that ingests JSON as its input. Hopefully everybody is seeing my screen again.
Good to go.
Okay, so up in the facet and filter column, there's the undo redo. So this lists all of the different steps that you used, and so you can always track it back, and then your changes will essentially get removed from the main data, and then you can of course take it back if you want. Now, in terms of repeating it again, you can extract your operation history here to a JSON file that essentially lists the steps. And so then if you were to bring in some other data, then you can click apply, and that's going to let you copy that JSON back in, and it would perform the same steps. If you can see my screen here, when we were doing our different facets, they were showing up here in the left-hand column. If you click on the undo redo link, it lists out the different steps that we've done so far. So create project, mass edit, the cells and business name, and so on and so forth. So if I screwed up, I didn't like the way that one of my operations turned out, I can step it back just by clicking on that that particular operation. So if I go back to before I started working on my revenue column, then if I look back at my revenue column, where did that go? Okay, we'll go one step back. Okay, so I stepped it back all the way through the operations I did on the revenue column. And so now the revenue column has gone back to that original format, which has both the dollar signs and the commas.
That's a good point.
Yeah, so the answer to that question is probably. And what I've experienced with working with OpenRefine is so say I have OpenRefine open and I just go to a website like, say, the New York Times or whatever, like so, that's probably going to work okay. Where I've seen issues with running the OpenRefine is if I try to go to a website that has like my password already entered, so like a pass-through authentication, I found that I've experienced issues with that pass-through authentication if I have OpenRefine running. And I just kind of chalk that up to the fact that we have kind of a local web server running. That's what I've experienced. I'm running Chrome and using it now, and I haven't. That's been the only issue I've experienced, but it is possible that that there could be other issues in Firefox or Chrome that come out. So once you've run all your modifications, so say, let me step back to after my revenue change that I made, you click export up here, and then you can choose whatever format you'd like. Say I'd like to export this back out to a comma separated value. You just export it that way, and then the updated data is going to show, or it will be in this exported file. So we're not making any changes to the original data. We're going to make the changes within the application, and then the application will export out those revised columns. All of the operations are associated with a specific column here. So you actually click on the drop down next to the particular column, and then that's what allows you to change. Now you can edit the column, you can split the column or create new columns based on information in existing columns. So you're not limited to only these columns. You can create additional ones and tack them on the end as well. That's another good question. For me, I have Chrome set as my default internet browser, and so I just opened OpenRefine and it automatically opened with Chrome. So my assumption is that it's your default web browser. Is that your experience as well, Doris?
Yes, because essentially, like you said, you're just opening it up in the browser and everything happens in that one browser. From what I've dealt with I've never had like a pop-up other than a pop-up to import your data. As you saw, it didn't do it in another it didn't do it in another like browser. You saw that it did it within that ecosystem of Google Chrome.
So I'm going to say your default web browser is what's going to be used there, because I do have other web browsers installed on this machine, but since Chrome was the default, it's the one that gets selected.